Hello once again, this is the Pencrest High School AP Physics 1 video series. This is video 9G, electrical measurements. Okay, this section we're going to look at the measurement of electrical quantities, resistance, voltage, and current. So first we'll look at the ohmmeter. The ohmmeter is used to measure electrical resistance. The ohmmeter uses its own circuit, so it's not to be used while current is actually flowing through an existing circuit. The ohmmeter provides a fixed voltage and measures the current through the resistor. Then application of Ohm's law provides the resistance such that R equals V over I. So here's an analog ohmmeter. It has a scale on its face and a red indicator hand that's right here, sort of a dial that goes back and forth. The dial is connected to a galvanometer which measures current. The ohmmeter produces a fixed voltage, so the dial is marked in ohms because the relationship is known according to Ohm's law. The ohmmeter knows its own voltage and measures the current, and then uses the relationship to determine the resistance of the resistor. Now here's a digital multimeter being used as an ohmmeter. The red lead is connected to the port that's marked voltage, milliamps, and ohms, which means it's to be used for resistance. Notice also that the dial is turned to the section marked ohms. It's down here. There's a number of scales available ranging from 200 ohms up to 2 mega ohms or 2 million ohms. Now we're going to go to current measurement. Ammeters are used to measure current. They measure current directly in an existing circuit, which means they have to be inserted into a circuit in series. We'd like the ammeter to disrupt the circuit as little as possible. So ammeters have a very small resistance, so it has a very small impact on the equivalent resistance of the circuit. Here's an analog voltmeter. It has a couple different settings. It can measure, on this scale it's up to a half an amp, or actually 0.6 of an amp, 0.6. On this other scale up here, it can measure up to 3 amps. Use a different lead to measure the different currents. Here's a digital multimeter. The dial can be moved to the section marked A. Here it is here, to serve as an ammeter. Notice again that it has several scales. This one is 200 microamps, all the way up to possibly 10 amps here. So it has a wide range of currents it can measure. Now, as far as the schematic diagram goes, the schematic symbol for an ammeter looks like this, a little circle with an A in it. It's got the two leads coming off the sides. If we'd like to measure the current through a specific resistor in a particular circuit, we insert the ammeter symbol in series right next to the resistor that we want to measure. So in the circuit shown on the left here, if we wanted to measure the current through R1, we insert the ammeter here in series with R1, and then its current, its display would read the current that goes through R1. Whatever current goes through the ammeter also has to go through R1 because they're in series. If we wanted to measure the current through R3, we could place the ammeter here. We would measure this current. If we wanted to measure the current through R2, we could put it here. R4, we could put it here on either side. So the key thing to remember about ammeters is that they have a very small resistance, and they're placed in series with whatever you want to measure. Next we have the voltmeter. Voltmeters are used to measure voltage drop. The measurement is made across a particular resistor. which means the voltmeter has to be placed in parallel with the resistor that we want to measure. Again, we want the disruption of the circuit to be as small as possible because the voltmeter is in parallel. We want it to have a very large resistance. When it's then placed in parallel to another resistor, it doesn't change the circuit's equivalent resistance all that much. Here's an analog voltmeter, the old school. It's got 3 different settings, 3 different leads. It can measure 1 volt, 5 volts, 25 volts. It's got a different internal resistance for each of those measurements. There's the digital multimeter. When the dial is set to the V settings, here's the V on the upper left. There's a large resistor inside the housing that's wired in series with the voltmeter, so that when you hook it up in parallel to another resistor, it has a very large resistance and doesn't change the circuit too much. Here's the schematic symbol for a voltmeter. Circle with a V in it, 2 leads. If we're going to measure the voltage drop across a specific resistor, we insert the voltmeter in parallel with the resistor we want to measure. So if we wanted to measure the voltage drop across R1, we drop the voltmeter in parallel like this. It shows we're going to measure the voltage drop across R1. If we wanted R3, we put it here. As a matter of fact, that would give us the drop across R2 also. So the key points to remember about voltmeters is that they have a large resistance and they're placed in an existing circuit in parallel. That's it for electrical measurement. That's it for our content. Next up, AP exam format and test taking strategy. Until then, enjoy, and I'll see you again soon.